Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami Ikhwan. So today I want to present about my group assignment with title The Future Trending of Communication Power System in Malaysia. So I'm the first presenter. So today I will present about 2 points. The firstly is introduction, and then the secondly is a communication transmission technique. So introduction. The modern power system structure become more and more complex. Communication is needed in probably every type industry, but this day, due to large enormous smart grid, our system place are very high and specific demands relate to the reliability, real-time message, low delay, and cyber security. The communication standard begin to be necessary with the growth to the telegraph and telephone networks in the middle of 20th century. Communication protocols were introduced a bit later in 1970s with the introduction of the first data network. So I will go to the second point, is the transmission common technique. So basically there are 7 transmission common technique that will can be discussed. The firstly is the power line communication channel PLCC. The secondly is the this line, and the third is the microwave backhaul link, and the fourth is the satellite link, and the five is the fiber optic link, and the next one is the radio, and the lastly is the wireless network. So all these the transmission technique have their advantage and disadvantage, can be discussed later in the future of communication in power system Malaysia. So that's all from me. Thank you.
Okay, my name is Muhammad Syafiq bin Muhammad Nasir. I will explain about common communication network topologies in Malaysia. Okay, firstly, type of topologies are point to point. Basic topology with a dedicated communication channel which stays permanently associated to the two endpoints. Okay, second topologies is star. The summary is every peripheral node is connected to the center node, name a hub or switch. The center node is the master and the peripheral node are the slave. Star topology is considered as a light topology for dimensioning and commissioning. Okay, the third point of topology is bus, used mainly in computer networks where every network is connected to one central data bus collected a backbone. Okay, fourth topology is ring. It is more reliable topology than bus and star. The overall network out throughput capacity is limited by the lowest traffic capacity link between two neighbors node. Okay, the fifth topology is mesh. Mesh topology is called also a fully connected topology. All the nodes are connected to each other, but the count of links increases quadratic related to the number of nodes. Okay, lastly, hybrid topology. Hybrid networks combine two or more of the above shown topologies. For example, a tree network is a hybrid topology which on its turn may be regarded as a combination between star network range in a hierarchical structure. Often that is the preferred model in many up-to-date communication models. Okay, that's all from me. Thank you.
Hello, I'm Isaac. So I will continue with consideration and input needed for proper dimensioning of communication network. Example input activities. The first one is to determination of number of site interconnected, control or monitor. Second one is to determine of the current traffic load and its expected growth. The third one, in case of an expansion, the topology and the parameter of existing communication network are determined. Number 4, determination of necessary quality of service, which is QoS, and security levels. Prioritization for delay sensitive traffic data must be provided. Timing demand is communication network for power system set very high level of timing delay requirement. This is a major issue in today mainly IP-based network, since the packet end-to-end transport in an internet-based network is generally based on the best effort service principle. The delay-sensitive traffic must be prioritized to comply with the delay frames set by different standards. Thank you.
Move on to security requirement. Reliability and efficiency have always been key design goals for a modern IT infrastructure and investigate for use in power system. During the last year, the security issue has also attracted care, mostly due to the fact that the previously isolated power system IT infrastructure is now evolving to be increasingly integrated with other IT infrastructure, also including public infrastructure. There are many reasons for this transition, and some of the most important these are increased use of Internet WAN as data transmission media and necessity of low cost. In figure below, a broad overview of a traditional power system communication network is shown. Connections between generation site, substation, control and management center are usually realized via public data network. Thus, number of measures should be taken in order to achieve effective defense against fraud attack. Okay, next go to communication protocol in power system. Legacy protocol, Modbus, developed in 1979 for process control system. Application layer messaging protocol that is positioned at layer 7 of OSI model. Used for client or server communications between devices connected to the same network. IEC 61850. Data modeling, object-oriented, platform-independent modeling of all functions, fast transfer of event and message. GOOS and GSSE for the peer-to-peer communication mode. Setting groups. Control block allow the user to switch from any active group of setting value to another. Sample value. Transfer of sample value from modern switchgear and nano-conventional CT or VTS. Data storage and representations. Configured data of the substation is stored in XML format using the substation configuration language SCL.
Now I will continue on the future trends part. The conventional power systems with more sophisticated information and communication technologies are expected to evolve into a new paradigm called a smart grid. Smart grid is an electrical grid which incorporates a variety of electrical devices and energy utilities like conventional generator units and substations, smart appliances, smart meters, renewable energy production sites, and energy efficient resources. Control of the production and distribution, quality and reliability of electricity are important aspects of the smart grid. Furthermore, security and sustainability have become major priorities to both industry and society. As the energy suppliers and customers are spread over large geographical area, the communication network should consist a layered architecture with core network and many peripheral network elements, gateways, which will interconnect all the suppliers, control centers and customers. Reliability and security provision in a strict time delay manner will be also very challenging issues for the new coming ICT structure. Lastly, we go to the conclusion. The electricity industry becomes increasingly competitive. Knowledge concerning the new market structure, legal and business constraints will become a commodity of great value. Electricity markets can be fast changing, and understanding the implication of these changes before others can give an important competitive advantage. ICT must be properly chosen to be effective, secure and future ready, but in a cost-effective manner despite of falling prices in the data communication sector. ICT also plays an important role to serve the drastically increased information flow exchange in smart grids. Power systems have specific demands and features that are not seen in other infrastructures, especially when it comes to reliability, security, and near real-time processes. That's all from me. Thank you.